Hi all, today we are going to study about response of second order system which comes under time response of feedback control systems. So already we have discussed about first order system and second order systems. Today we are going to study only about the response. We have to go for 4 conditions: undamped, underdamped, critically damped as well as overdamped. Today in this session we will just go through undamped and underdamped. So we know that the transfer function is very much important for a system. So in this we have to go through the transfer function of a second order system. So the second order system transfer function is given by C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. And we know that for undamped system the zeta will be equal to 0. It is represented as z here. Z is equal to 0. Once we substitute z is equal to 0 or zeta is equal to 0, you will get the C of s by R of s as omega n square divided by s square plus omega n square. Now we are going to study about undamped second order system for unit step input. Unit step in the sense R of t will be equal to 1. Hence, if you are taking the Laplace of the corresponding thing, it will become R of s is equal to 1 by s. The response in S domain is given by C of s is equal to omega n square divided by s square plus omega n square into R of s. You can rewrite the equation like that. And now what you have to do in the sense, you have to replace the R of s by 1 by s. So that the equation will become C of s is equal to 1 by s into omega n square divided by s square plus omega n square. If you are applying the partial fraction, you can get the equation as a by s plus b by s square plus omega n square. Now you have to find the value of a and b as we have applied the partial fraction. So a is obtained by multiplying C of s by s and letting s is equal to 0. You can see over here I have substituted as a is equal to C of s into s when s is equal to 0. So you know that what is C of s? C of s is nothing but omega n square divided by s into s square plus omega n square into s letting s is equal to 0. So that what you will get means s will get cancelled. Remaining is omega n square divided by s square plus omega n square as s tends to 0. So s tends to 0 means the equation can be modified as omega n square by omega n square, which will become equal to 1. So you will get the value of a as 1. Now we have to find out what is b. b is obtained by multiplying C of s by s square plus omega n square and letting s square is equal to minus omega n square or s is equal to j into omega n. So you can see the equation over here. B is equal to C of s into s square plus omega n square letting s is equal to j omega. So you have to substitute what is C of s. C of s we know that omega n square divided by s into s square plus omega n square into s square plus omega n square letting s is equal to j omega. So if you are substituting like this, you can see that s square plus omega n square is there in both numerator and denominator. It will get cancelled and remaining is omega n square by s letting s is equal to j omega n. Now you have to substitute s by j omega n so that you will get omega n square divided by j omega n. You can see in the numerator it is omega n square and denominator is omega n, so that 1 omega n will get cancelled. Remaining is j omega n by j. 1 by j is nothing but minus j, so it will become minus j into omega n, which is equal to minus s, which you have already substituted here. You can see in the previous step you have substituted as s is equal to j omega n, so you can keep c over here. Minus j omega n is taken as minus s. Now we can go to the partial fraction. The equation was C of s is equal to a by s plus b by s square plus omega n square, so that we can rewrite the equation by a and b. That is equal to 1 by s minus s by s square plus omega n square. That is your C of s, which you have got it. Now what you have to do in this sense, you have to take the Laplace transform, inverse Laplace transform of the corresponding equation, so that you will get what is C of t. Time domain response, C of t is equal to inverse Laplace transform of C of s. It's equal to L inverse of 1 by s minus s by s square plus omega n square. So L inverse of 1 by s is nothing but 1, and L inverse of s by s square plus omega n square is cos omega nt. So the equation of C of t is equal to 1 minus cos omega nt. This is the equation of undamped second order step for unit step input. You can see the waveform over here. It is unit step which I have given, and the response output what you are getting is undamped. So for a closed loop undamped second order system, unit step response is 1 minus cos omega nt, and if it is a step response, instead of that equation, it has to be multiplied with A, as we have already discussed in the previous slides. When you are going for unit step, A will be considered as 1, so you got unit step response. You can see both the equations here. Unit step response is 1 minus cos omega nt, and the step response is A into 1 minus cos omega nt. This is about undamped equations of a second order system. Now we'll move on to the underdamped. Again, you have to remember one thing. We have to consider the control system or C of s by R of s transfer function as the same thing which you have studied already, omega n square by s square plus 2 zeta omega ns plus omega n square. All the 4 cases the control function is or transfer function is same only thing is the zeta value will vary. Previously it was varied to zeta is equal to 0, so you have substituted and you have identified like that. Now for underdamped, we have to go for considering 0 less than zeta less than 1, and the roots of the denominator are complex conjugates. So we have already identified the roots previously. The value of s is equal to minus zeta omega n plus or minus omega n into root of zeta square minus 1. Since zeta is less than 1, zeta square is also less than 1, so that 1 minus zeta square is always a positive value. So that we can take the equation of s as minus zeta omega n plus or minus omega n into root of minus 1 into 1 minus zeta square. So when you simplify this, you will get the equation as minus zeta omega n plus or minus j omega n into root of 1 minus zeta square. So we have already gone through damped frequency of oscillation, which we call it as omega d. So omega d is nothing but here you can see it is minus zeta omega n plus or minus j omega n into root of 1 minus zeta square. So damped frequency is called as omega n into 1 minus root of 1 minus zeta square. You can see over here omega d is equal to omega n into root of 1 minus zeta square. The response in S domain is C of s is equal to R of s into omega n square divided by s square plus 2 zeta omega ns plus omega n square. As we know that we are applying for unit step input, R of t will be equal to 1 and R of s will be equal to 1 by s. So what you have to do in this sense, previous equation you have to substitute R of s as 1 by s. So C of s is equal to 1 by s into omega n square divided by s square plus 2 zeta omega ns plus omega n square. Now we have to apply the partial fraction, so the equation will become a by s plus bs plus c divided by s square plus 2 zeta omega ns plus omega n square. So we have to apply the Laplace, you have to apply the partial fraction equation to find out the a, b and c values. A is obtained by multiplying c of s by s and letting s is equal to 0. Previously also we have seen the method is same only thing is the equation is getting varied. So a is equal to s into c of s while setting s is equal to 0. So you can see the equation over here, ss will get cancelled, remaining is omega n square divided by s square plus 2 zeta omega ns plus omega n square. If you substitute s is equal to 0, this s square and 2 zeta omega ns term will become vanished and remaining will be omega n square divided by omega n square, which will be equal to 1. So you got a as 1. Now we have to find out both b and c. So how we will find out b and c? In the sense you have to equate the power of s. So and what you have to do in the sense, omega n square is equal to s square plus 2 zeta omega ns plus omega n square plus bs plus c into s. Okay, that is the equation how we are equating. And now what you have to do in the sense, you have to substitute a is equal to 1, but here we don't have any a, remaining things you have to substitute. So you can see here s omega n square is equal to s square plus 2 zeta omega ns plus omega n square plus you substitute, you cross multiply this bs into s, it will become bs square plus c into s. Now we have to take the coefficients of s square and let it consider for b. Equating coefficient of s square, we get 0 is equal to 1 plus b. So therefore b will be equal to minus 1. Now we have to equate the coefficient of s so that we can find out what is c. So when you are equating the coefficient of s, we will get 0 is equal to 2 zeta omega n plus c. From that we can find what is c. So c will be equal to minus 2 zeta omega n. So if you know the value of a, b and c, that thing can be substituted in the equation so that you will get c of s is equal to 1 by s minus s plus 2 zeta omega n divided by s square plus 2 zeta omega ns plus omega n square. Let us add and subtract the zeta square omega n square to the denominator of the second term in the above equation. So what you will get in the sense, once you substitute over here, you can see over here. Why you are doing in the sense, you have to find out what is omega d. You have to find out what is, what is omega d also. So what you have to do in the sense, you have to add and subtract those terms. So if you do like that, you can find what is C of t very easily. So see the equation over here, C of s is equal to 1 by s minus 2s plus 2 zeta omega n divided by s square plus 2 zeta omega ns plus omega n square. Now we are adding and subtracting zeta square omega n square. So you can see over here. Then you have to arrange the equation in such a way that we have to include the omega d, as we know the omega d as omega n into root of 1 minus zeta square. So once you substitute all those things, you can see the equation over here, 1 by s minus s plus 2 zeta omega n divided by s plus zeta omega n square plus omega n square into 1 minus zeta square. So you know that omega n square into 1 minus zeta square is related to omega d. So you have simplified and you have written it as 1 by s minus s plus 2 zeta omega n divided by s plus zeta omega n square plus omega d square. Let us multiply and divide by omega d in the third term of the equation, so that we will get it as 1 by s minus s plus zeta omega n divided by s plus zeta omega n square plus omega d square minus zeta omega n divided by omega d into omega d divided by s plus zeta omega n square plus omega d square. Now we have to apply inverse Laplace transform for the above equation. Once you apply inverse Laplace transform for the above equation, we will get it as C of t is equal to L inverse of C of s, that is equal to L inverse of 1 by s minus s plus zeta omega n divided by s plus zeta omega n square plus omega d square minus zeta omega n by omega d into omega d by zeta s plus zeta omega n square plus omega d square. This we have to make it in a format. That's why we have added all these things, as well as we have multiplied by and divided by omega d also. Otherwise we cannot make it in the format of e power minus at sin omega t as well as e power minus at cos omega t. So once you do all these things, we have the general equation in such a way that omega by s plus a the whole square plus omega square is equal to L inverse L of e power minus at sin omega t, as well as s plus a divided by s plus a the whole square plus omega square is equal to L of e power minus at cos omega t. So you have to bring in such a form. That's what we have gone for, multiplying and dividing omega d in the third term. So you will get the equation as 1 minus e power minus zeta omega nt cos omega dt minus zeta omega n by omega d into e power minus zeta omega nt sin omega dt, which when we simplify we will get it as 1 minus e power minus zeta omega nt divided by root of 1 minus zeta square into sin omega dt into zeta plus cos omega dt into 1 minus zeta square. That will be an equation of C of t when we are considering the underdamped second order for a step response equation. So let us express C of t in a standard form as shown below. C of t is equal to 1 minus e power minus zeta omega nt divided by root of 1 minus zeta square into sin omega dt into cos theta plus cos omega dt into sin theta. So this is nothing but sin a cos b plus cos a sin b, so that we can write it as 1 minus e power minus zeta omega nt divided by root of 1 minus zeta square into sin a plus b, sin omega dt plus theta, where theta is nothing but tan inverse of root of 1 minus zeta square by zeta.